This lesson combines all three sections of Unit 3, Solving Polynomial Equations. We're going to talk about the best method to use for each type of problem. So the method of graphing to solve a quadratic is best used if you have graphing software or if it's already written in vertex form for you. Some of the limitations of this method is it will not give you exact answers if the answers are irrational, and it also cannot be done if the solutions are imaginary. So what we would do is we would graph the equation, look at its x-intercepts, and that would be the solutions. The next method is factoring. So the factoring is best used when the discriminant is a perfect square. Also, it's usually the first one we'll attempt to do, the first method when we're solving a quadratic, as it usually is the easiest method. The limitations, though, are not all quadratics are factorable. So how it's done, if there's no term in front of the x squared, we find the two numbers that multiply to b and add to c. Multiply to c and add to b. And then we write them in sets of parentheses and solve each. If there is an a, if there's a number in front of the x squared, we're going to do a times c first, then find those factors that add to b. Then we're going to write them as fractions, ax over p and ax over q, and then simplify, if we can, place each of those into parentheses and solve each. The method of solving by square roots is best used when there's no linear term, which means there's no plain x. The limitations is it cannot be used if there is a plain x term. So what we would do is I would get the whatever's being squared alone. If it's just an x being squared or a set of parentheses being squared, we get that alone. Then you take the square root of both sides, remembering that you have to include both the positive and negative answer. The method of completing the square is best used if there's no number in front of the x squared and the b term is even. The limitations is it's not actually a very common method we would use. There's other things we would do before we go to completing the square, and we can only easily do it when a is 1 and b is even. So the way to do this is we would isolate the variables. We'd get all of the variables on one side, the number on the other. We take half of b, square it, and add it to both sides, and then we factor the left side, simplify the right, and then it becomes a square root problem. And our last method is the quadratic formula. So it's best used when something's not factorable or the solution is imaginary. The limitations are it does take more time, it has a lot of steps, but it will work on every single one. Technically, even if it was a solve by square roots problem, b would be 0 then. So it'll work on every problem. So how it's done is we're going to identify our a, b, and c once it's equal to 0. We're going to plug it into the quadratic formula and solve. And sometimes it helps to do the discriminant first, and then we have less work inside the quadratic formula. So we're going to look at some problems, and we're going to see which method we would do for each of these. There may be more than one right answer for how you would choose to do it, but I'm going to just show you one method. So for this one, I have x squared minus 12x plus 100 equals 6. So I have no number in front of the x squared, and b is even. So this could be done by completing the square. All right, I'm going to say because a equals 1 and b is even. All right, I could also have done this by quadratic formula. Factoring would not actually work on this one, because if I tried, if I say like I subtracted the 6 here, I got 94, there's no two numbers that multiply to 94 that add to negative 12. So it's not factorable. So I'm going to solve it by completing the square. So that means I'm going to move the 100 over first. And if you recall, we're going to take half of negative 12, and we're going to square it. So that's going to be plus 36 on both sides. So now we're going to have x squared minus 12x plus 36 equals negative 58. I'm going to rewrite this as x minus 6 squared equals negative 58. And now I'm going to take the square root of both sides. Right now it's a solve by square roots problem. So x minus 6 equals plus or minus square root of negative 58. This doesn't reduce the 58, but the negative will come out as I. And the last thing to do would be add 6. So x equals 6 plus or minus I root 58. Okay? Let's look at another problem. So this one, I could try to factor it, and if it doesn't work, I would go to quadratic formula. But I'm going to choose to try to factor it because that's the easiest method. Because it's the easiest method. So that means I have to get it equal to 0. So we'll add the 3. So I'm going to take 2 times 3 is 6. And the things that multiply to 6 to add to 5 are the 2 and the 3. So I'm going to take 2x over 2 and 2x over 3. This one reduces. So that's x plus 1. Hold on. All right, and then the other one here would be 2x plus 3. And since each equals to 0, we solve each one. So we get our two answers that way. Looking at the next one, I don't have an x term. I have an x squared but no x. So the best method for this would be square roots because no x term. So in this one, we want to get x squared alone. So we would start by subtracting 2. And we could divide by 9. And then we take the square root of both sides. 47 can't be reduced. It's a prime number, so that actually stays like that. And we're done. All right, on the next one, I have an x and I have an x squared, so I can't do square roots. I could try to factor it. If I subtract 1, 1 times 2 is 2. Nothing multiplies to 2 and adds to negative 8, so that cannot be factored. So I'm going to go ahead and do quadratic formula. Because it always works. If I'm unsure of what method would be best for it, quadratic formula will always work. So I'm still going to get it equal to 0. So my a is 2, my b is negative 8, my c is negative 1. So I'm going to start with b squared minus 4ac. Said 64, 2 negatives is a positive, 8, and we get 72. All right, and this just shows that it's not factorable because the discriminant is not a perfect square. If it was a perfect square, it would be factorable. So I'm going to plug it into the quadratic formula. So that's opposite of b plus or minus the square root of 72 all over 2 times 2. 72, if I look at 72, 2 times 36, and 36 is a perfect square. So 72, if I was looking at it like this, it'd be 6 radical 2. So here, I'm going to have positive 8 plus or minus 6 radical 2 all over 4. And here, 8, 6, and 4 are all divisible. Oops, that's not at all the symbol I wanted to do. All divisible by 2. So if I divide everything here by 2, x is going to equal 4 plus or minus 3 radical 2 over 2. And that's my answer for this one. My next one, I have 1 in front of the x squared, but this is odd, so completing the square wouldn't be great. I could try to factor it, right? Because that's the easiest. And we'll make sure it works. So x squared plus 9x plus 8 equals 0. Things that multiply to 8 and add to 9 are 8 and 1, so that does in fact factor. So if we set each one equal to 0, I get negative 8, and I get negative 1. The last one I'm going to look at here, I have a set of parentheses being squared and no other x terms, so this is going to be by square roots. because no x term. So I'm going to get this set of parentheses alone, so I'm going to add 15 first. I'm going to take the square root of both sides, so I'm left with x plus 12 equals plus or minus square root of negative 75. So negative 75, right, breaks down to 3 and 25. So this is an I and a 5, and that stays as root 3. So on this side, we have 5I root 3. So now I'm going to subtract 12. And x equals negative 12 plus or minus 5I root 3. So you're going to try this set for each one, solve by a different method. Well, I shouldn't say a different method for each one. Try to use at least 3 different methods. Explain why you chose each method and solve. You could pause it and I'm going to show answers. All right, so here are our answers. For number 1, I chose to do quadratic formula because it was the only one that was going to work, right? There was no number, there was a 12 in front of the x squared, so completing the square wouldn't work, and it's not factorable because there's an imaginary solution. Number 2, you could choose either completing the square or quadratic formula because there was no number in front of the x squared and the b term was even. But quadratic formula always works, but completing the square works because it was 1 and even. For 3, there's no x term, so I chose square roots. For 5, there's no x term, so I chose square roots. Sorry, for 4. For 5, I chose to factor because it's the easiest way to do it as long as it works. But I could have done quadratic formula as well. And same thing for 6, factoring or quadratic formula. And that is our lesson on choosing the best method.